You are listening to Science Coast with Mallory Havens and
Chris White.
And today we have no guest.
Yay!
No, boo.
No, we get to talk about whatever we want to talk about.
Yeah, that's true.
When we have a guest, we have to listen to them.
Yeah, that's true. Today I wanted to talk about Neuralink, which is Elon Musk's company that is working on brain-computer interfaces, and their new brain chip called telepathy that has now been put into a person.
So, wait, you're saying that they're actually putting silicon chips into people's brains?
I don't know if it's made of silicon. I assume.
Oh, computer chips.
Yeah.
Okay.
But yes, so they are drilling holes through your skull, and not through. They've only done this in one patient.
I have to say, what I just imagined was like this oil derrick being mounted onto somebody's head.
Oh.
And then like a little miniature one and drilling a hole, and that's not how it works?
No.
Okay,
No.
sorry.
But good thought. It's the plug from the Matrix in the back of the head. I'm just kidding. It's not. So they drill a hole through the skull and implant this chip, and then it is supposed to detect your brain waves and be able to communicate those out via Bluetooth to a computer so that you can control the computer with your mind and not your body.
So why? Because, I mean, I'm quite content, using my hand
to move your mouse.
To move my mouse around. So, I mean, I know that there's probably a good reason. So what's the reason why people want to do this?
Well, at this point, they're putting it in patients who are quadriplegic.
Oh.
So they can't use any of their limbs. And so it would be a way, current technology for people who are quadriplegic or can't speak is to move their eyes to look at letters, to have computers talk to them and detect the eye movement. But this would be you would be able to do more with this functionality, controlling a computer. And I can envision down the road that they might try to have it, the exoskeletons that they're trying to make for people who are paralyzed to be able to control that and move it via brainwaves.
So didn't Stephen Hawking use that technology where he could type things out using his eye movements?
Yes.
I went to see him once, and he took questions. So he had a prepared lecture where, he in his wheelchair was up on the stage, and then he had prepared the lecture in advance, so it just read out. But then he took questions, and then live on stage was answering people's questions, which I thought was just amazing.
With the eye movement and the computer would talk?
Yes, because he was completely incapable of other motion at that point.
Yeah.
So, and yes, we had to wait several minutes for him to actually type out using his eye movement what his answer was.
I bet you'd get really good at condensing your thoughts.
Yes. And I'll just share with the audience. The one answer that I remember very, very clearly was in his talk. He was talking about imaginary numbers and referring to imaginary numbers as not being real. And then, so of course, a mathematician in the audience challenged him on this notion that imaginary numbers weren't as real as real numbers were. And his response was, maybe you can eat an imaginary apple, but I cannot.
Well, there you go.
I mean, it's a kind of a jerky way of answering the question, but at the same time, I remember it.
That's funny.
So what do these devices look like? Have you seen one?
I haven't seen one, but they're relatively small. I think the kind of interesting things that are happening here is, one, this company, Neuralink, got in trouble for their animal trials leading up to this.
Wait, they got in trouble for it? What'd they do?
There were some bad outcomes, such as primates that had to be put down from infections. One of the devices broke during surgery to implant it, resulting in infection. And there were several other issues where they came down on them for how they were treating the animals in the trial and some of the outcomes. But they did get approval last year to move into human trials, and from the FDA, and they've only put it in one person so far. But it's a little concerning when you have some poor animal outcomes and then are moving straight into humans. And also, I understand this technology fully for people who have mobility issues or other ways that they're incapacitated and cannot do normal physical movement or use technology. But that's not the goal of Neuralink. Yes, they're starting there, but their goal is to make this widely available to people to be able to control devices with their minds.
So yes, Elon Musk. I can imagine. This is his dream for the future is that we will all have brain implants.
We'll be cyborgs
that we use to control the world in which we live, which is a little bit of a dystopian future, if you ask me.
Yeah, it creates all these issues where you can have part of the population that can afford to be enhanced and part of the population that is not enhanced, and this starts some sort of classism where people who can't afford a brain chip can't have the processing power or the ability or access to things.
I think there's also a big privacy issue. If you're broadcasting your brainwaves by Bluetooth, how do you keep them secret from other people? And I think there have to be some considerations as to, are we really interested? I know people put all kinds of stuff out on Facebook, but are you ready to broadcast your thoughts via Bluetooth to the world?
I certainly am not. It's a dark place in here.
Just open your eyes, Mallory. Open your eyes.
Well, it's also concerning if that kind of leads to a dystopian idea of if you have a bad thought, can you be prosecuted for your thought being immoral or wrong?
So you can if you say things out loud. There are certain things that you're not allowed to say,
like scream fire in a building.
And it's interesting because then it's a matter of whether how well regulated your brain is.
Mm-hmm.
So if you have a well regulated brain and you're able to control your emotions to the point where you're not exhibiting outwardly what's happening on the inside, but now with this brain chip, what you're suggesting is that we'll have access to what you're actually
My
feeling.
brain waves are yelling fire in a public building, or if somebody has in the middle of a fight a rageful thought of punching someone and they don't actually do it, but they're thinking physical violence, can we be like, oh, that's a violent person?
Interesting thoughts. I think we're going to have to explore those. There's clearly some gray areas here, but this is farther down the road. Can we get back a little bit more to what happened? I guess, was it last week when they did this? Or when did this surgery take place?
I think it was last week. It was fairly recent. I don't remember the specific date. So far, it's been publicized that the patient is doing well, and
So they haven't died yet.
They haven't died yet. And telepathy, the chip itself, has been able to pick up neuronal spikes.
What is a neuronal spike?
So when you can look at brainwaves on digital outreads, and you have different kinds of brainwaves for alert versus asleep. And you have different outputs for different regions of your brain at different times. So literally all of your thoughts are electrical activity.
So brainwaves are electromagnetic waves that can be detected using electrodes placed on the skull. Is that what you're saying?
It can be, yeah. And I'm not entirely sure exactly how the brain chip works, but it is placed into a region of a brain. So far it was placed in the region of a brain that controls like movement. So I can't envision a single brain chip being able to detect all regions of your brain simultaneously, because there is distinct regions that do distinct functions. Like you have a motor cortex, and you have a somatosensory cortex, and you have a visual cortex, and you have different areas for hearing language and understanding it versus being able to generate language. And so there's all different regions that have specifications, but then everything is also much more integrated than that. So if you have a thought or a memory, it's not just located in one spot. So say you imagine grandma, and you get both your limbic center activated because presumably you love grandma, plus maybe you have parts of your brain that remember what grandma looked like, and then maybe parts of your brain that remember what grandma's house smelled like, and then you remember specific events. And these are all located in different regions, but they interact. And that interaction is really just the movement of ions in and out of your cells, and then the release of neurotransmitters at the end.
I think when I was looking at this, I saw this in the news as well, and I was reading a little bit about it, and they were talking about inserting little wires that connect to the brain chip, to the chip, into various regions of the brain, so that the chip is probably relatively compact, so that, to your point, it is only going to have physical contact with a very limited part of the brain, and so then they have these thin wires, apparently leads, that are attached to the probe that can then get inserted into other parts of the brain to basically expand out the regions at which it can have electrical, like an antenna almost.
Yeah, that makes sense.
And but it's weird for me as a physicist, because I've built lots of apparatus to do all kinds of physics experiments, and the electronic signals that we get can be conducted via optical fibers or cables or through electromagnetic waves. And so I was sitting imagining the physics of capturing a brainwave inside the skull on a computer chip. And one of the things that I came up with is that there's no connection. There's not like, oh, this is the neuron. This is the exact point in the brain that is where the brain is controlling how you move your fingers. So if we're going to help people do that, this is where we want to put the lead. We don't know that. So the brain, in some sense, has to learn how to use the wires. And it's almost my understanding and my thought is that it's a trial and error, where you put these leads into various parts of the brain, and then the person has to learn. The brain has to develop and modify itself to be able to use those leads to do things. And that's just so fuzzy to me. And maybe, I don't know if you can help elucidate.
I think if you think about classic brain surgery, say they're going in to remove a tumor, prior to doing that, they electrically stimulate different regions of your brain to see what that does for you, so they don't damage a region that's really important.
So they're mapping out the brain.
Yeah, and you can do stuff like this with, like, say you play the piano, and they can touch a part, and then you're like, oh, I know how to play the piano. So the patient has to be awake. You can touch regions, and they're like, oh, I smell broccoli or whatever, and you can kind of map it out that way. They also map it out with functional MRIs, where you can look at oxygen consumption. And so when a certain part of the brain is active, you can see more use of oxygen because it's using more energy, or you can see where glucose is being consumed. So they map it out with MRIs. They can map it out with electrical probes, but it's a little bit different for each person. So where you house your individual information is not exactly where I house mine. We have the same basic brain structure, but we can put it in different neurons. Or if one of my neurons dies, which probably happens more often than I want, there's other neurons that can pick up the tasks and do that for me. So our brains have plasticity, we say, where they can have changes, and we can alter pathways and learn new things and change synaptic connections after birth. So this leads to, if you have brain damage, then your brain's going to have to relearn how to use itself plus its wires.
Aren't there examples of people who, I think you just brought this up, people who have some type of an injury or a trauma that damages parts of the brain, and then other parts of the brain have to learn how to take over that function?
Yeah, that's why stroke recovery or brain damage, like internal bleeding or removing of a section because of a tumor, there's a recovery period, and there's physical and occupational therapy where you figure out how to do these things again. I have an uncle, and it's pretty amazing, who had a stroke where half of his brain died, and he can walk again.
That's amazing. So again, it's hard for me to imagine that we know how to identify places in the brain to put these chips. I'm just at a loss for words as to where this is going to go.
I'm not lining up for it anytime soon.
Yeah. But I guess hopefully this type of research will allow us to learn more, so that people who have had traumatic brain injuries and have lost function will, have better lives as a consequence of this research. So I know it sounds a little bit scary, but I think the goal and the intent is to restore quality of life for a subset of the population that's just suffering right now.
Yeah, for sure. And to be clear, Neuralink is not the only company who is trying to do this. There are other companies working on this too. It probably just gets the most news because it's actually been put in people, and it's Elon Musk.
I think I've also heard about, to that point, people who are working on photosensors for blind people to put in implants so that they can begin to have sensitivity to light impulses.
Sure. Yeah. It's amazing what technology may be able to do for us in the future, but taking a perfectly healthy person and trying to enhance them leads to a lot of gray areas, as opposed to somebody who's restoring function.
Very cool.
And with that, the views, thoughts, and opinions expressed are the speaker's own and do not represent the views, thoughts, and opinions of Lewis University. The material and information presented here is for general information purposes only. The Lewis University name and all forms and abbreviations are the property of its owner, and its use does not imply endorsement of or opposition to any specific organization, product, or service. This podcast was produced in the WLRA podcast studios at Lewis University. Visit lewisu.edu for more information about Lewis. This has been Science Coast with Mallory Havens and
Chris White.
Bye.